Hello my dear students, welcome to my YouTube channel as Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I am going to teach you a topic that's hydrogen spectrum. In the previous lecture, we have studied about the emission spectrum and the absorption spectrum. Now we are going to study the emission spectrum for the hydrogen atom. First of all, as we all know that hydrogen is a uni-electronic atom, that is one electron in its first orbit only. When the energy is supplied, the electron jumps from lower orbit to the higher energy orbits. So let me write this thing first. So I'm writing, as we all know that hydrogen is uni-electronic element, that is, it has only one electron in its first orbit, and we all know that the first orbit is the lowest energy orbit. The first orbit has the lowest energy, so it can also be called as the lowest stationary state or the orbit with the lowest energy. So what will happen when energy is supplied to that electron? When energy is supplied to that electron, the electron will jump from first orbit to the any of the further orbits. That is, it can jump to orbit number 2 or the orbit number 3 or the orbit number 4, or like stationary state number 2 or the stationary state number 3 when the energy is supplied. To which stationary state the electron will jump will depend upon the amount of energy that have been applied to that electron. So after that, what will happen? Now electron will make a transition. Now the electron will make a transition from that higher energy orbit to the lower energy orbit. Lower energy orbit, or you can say that it can come back to the first orbit. So during that transition, the electron will emit, I'm writing, during that transition electron will emit photon whose energy will be equal to the energy difference between the two stationary states, whose energy will be equal to the energy difference between two stationary states or orbit, between two stationary states or orbits between whom electron is transiting. Now that photon emitted, that emitted photon, that emitted photon will be made to strike on the photographic plate, will be made to strike on photographic plate to obtain some impressions, to obtain some impressions. You can say that spectra, to obtain a spectra, and is termed as hydrogen spectrum, and is termed as hydrogen spectrum. Now, in hydrogen spectrum, there are different group of lines. In hydrogen spectrum, there are different groups of lines which are dependent on the final orbit in which electron is entering, from higher stationary states. Accordingly, that we have 5 group of lines. That 5 group of lines are Lyman series, Balmer series, Bastion series, Brackett series, and Pfund series. Now let's talk about these different series in a bit detail. So I have already made different orbits of the hydrogen atom. Let me firstly number them. Now let this orbit to be the number 1 orbit. Here I am writing n. This to be the first orbit, the second orbit, the third orbit, the fourth orbit, the fifth orbit, the sixth orbit, and finally the infinity orbit. Now now I am making a table for you for easy understanding. So first of all, let's talk about Lyman series. Firstly, let's talk about Lyman series. The spectral lines of Lyman series will be obtained when electron transits from any higher stationary state to the first orbit. So here I am mentioning first of all the final orbit in which the electron is entering, the initial orbit from where the electron has started the transition. So in case of Lyman series, the electron is transiting in first orbit. Finally, the electron is transiting from any higher stationary state to the first orbit. So n final in case of Lyman series will be 1 and n initial can be 2 or 3 or 4 up to infinity. So let's have a look on the diagram. Here Lyman series will be formed. The Lyman spectral series will be formed when electron makes a transition from second stationary state to first stationary state, or finally third 3 to 1, third stationary state to first stationary state, or fourth stationary state to the first stationary state, or from fifth stationary state to the first stationary state, or from sixth stationary state to the first stationary state, or finally from infinity stationary state to the first stationary state. So the lines of the spectral series obtained from the photons that have been emitted when electron makes a transition from any higher stationary state but to finally first orbit or the first stationary state, that group of lines will be termed as the Lyman series. Now let's talk about the first line of the Lyman series. Here I am writing first line of transition, first line of any spectral series or photon of minimum energy that have been emitted during that transition. The first line, you can see the diagram, the minimum energy gap between the minimum energy gap in the transition to finally the first orbit will be of transition of second orbit to the first orbit. Now you can see that 3 to 1 is having more energy gap, 4 to 1 is having more, 5 to 1 even more, 6 to 1 even more, infinity to 1 the maximum. So the minimum energy gap is from transition of second orbit to the first orbit. So that line will be of transition of electron from second orbit to the first orbit. So the transition of electron from second orbit or second stationary state to the first stationary state will emit the photon of the minimum energy, and that will be the first line of the Lyman series, so whose transition is second transition, transition is from second stationary state to the first stationary state. So now let's talk about the limiting line or the last line. Now here I am writing limiting line, or more specifically the last line of Lyman series, or the photon of maximum energy that have been emitted during the transition to the first orbit in case of Lyman series. So the maximum energy gap, you can see the diagram, the maximum energy gap is from infinity to 1. So when the electron makes a transition from infinity stationary state to the first stationary state, it will emit the photon of the maximum energy, and the line obtained during this transition will act as the last line for the Lyman series. So the last line or limiting line for the Lyman series is for the transition of electron from infinity orbit to the first orbit. So here I am writing transition from infinity orbit to the first orbit. The line obtained for the transition of electron from infinity orbit to first orbit will act as the limiting line or the last line for the Lyman series. So that was the first series, the Lyman series, where the n final was 1. The electron is finally transiting in the first stationary state from any higher energy stationary state. So now let's talk about the second series. Now the second series is Balmer series. Here I am writing Balmer series. Now, in case of Balmer series, the electron will transit from any higher stationary state to the second orbit or the second stationary state. So please do have a look of the diagram. Now, electron will transit from any higher stationary state to the finally second stationary state or the second orbit. Now, is the transition of 4 to 2. This is the transition of 5 to 2. This is the transition of 6 to 2, and finally there is a transition of electron from infinity orbit to the second orbit. So the photons will be emitted. You will get the second group of lines called the Balmer series, in which the electron will finally transit to the second stationary state or the second orbit, and initial stationary state will be 3, 4, 5 and so on up to infinity. So now again let's talk about the first line of the Balmer series, in which the photon of minimum energy will be emitted. That transition will be, you can see that diagram, the minimum energy for Balmer series is for the energy gap of third orbit to the second orbit. So here in case of Balmer series, the first line will be obtained by the transition of electron from the third orbit to the second orbit. And now let's talk about the limiting line or the last line, where the photon of maximum energy is emitted. You can see the diagram that maximum energy gap is from infinity to second orbit in case of Balmer series. So here the last line or limiting line will be of transition of electron from infinity orbit to the second orbit. So that was the Balmer series. So now let's talk about third series called Bastion series. Now the third series is Bastion series. Now let's talk about the Bastion series. Now in case of Bastion series, now electron will transit from any higher stationary state but finally to the third orbit or the third stationary state. So you can see the diagram. Here the electron will transit from any higher stationary state but to third orbit. So I'm taking a transition of 4 to 3. Now this is the transition of electron from 5 to 3. This is the transition of electron from 6 to 3. Now this is the transition of electron from infinity to 3. So in case of Bastion series, the electron will finally transit in the third stationary state or the third orbit, and initially the electron will be present in 4, 5 or 6 up to infinity orbit. So now let's talk about the Bastion series. The first line for Bastion series, the photon of minimum energy that have been emitted for the transition of electron from, you can see the energy gap, the minimum energy gap is from 4 to 3. So the first line will be obtained for the transition of electron from the fourth stationary state to the third stationary state. So now let's talk about the limiting line of the first line. You can see the diagram, the photon of maximum energy that will be emitted for the transition of infinity to 3. The maximum energy gap is between infinity to 3 in case of Bastion series. So the limiting line will be of transition of electron from infinity orbit to the third orbit. So this was the third group of lines called the Bastion series. So now let's talk about the fourth series called Brackett series. Now let's talk about Brackett. Now in case of Brackett series, the electron will make a transition from any higher stationary state but finally to the fourth orbit or the fourth stationary state. Now you can see the diagram. I'm making a transition of electron from fifth stationary state to the fourth stationary state, or from sixth stationary state to the fourth stationary state, or from infinity stationary state to the fourth stationary state. Now here, so the final stationary state in case of Brackett series will be number 4, the fourth orbit. So the initial stationary state from where electron is starting their transition is 5 or 6 or 7 up to infinity. Now in case of Brackett series, the first line, that is the photon of minimum energy, is photon of minimum energy emitted from which, for which transition, that is the minimum energy gap, that's from 5 to 4. So the first line will be of minimum energy gap, that is the transition of minimum energy gap, sorry, that's from 5. The first line will be of transition of 5 to 4. The electron will make a transition from fifth stationary state to the fourth stationary state. Now let's talk about the limiting line or the last line, that is the photon emitted of maximum energy will be of transition of electron from infinity orbit to the fourth orbit. So I'm writing from infinity orbit to the fourth orbit or the fourth stationary state. So that's the Brackett series. Now let's finally talk about the last one, called Pfund series. Called Pfund series. Now let's talk about the Pfund series. In case of Pfund series, again the electron will make transition from any higher stationary state but finally to the fifth orbit or the fifth stationary state. Now electron will make a transition from any higher stationary state to the fifth stationary state or the fifth orbit, and here the limiting line, the last line, is from infinity stationary state to the fifth stationary state. So let's talk about the Pfund series. Here the final stationary state will be the fifth one, the fifth orbit. So the electron initially will be present in 6th or 7th or 8th up to infinity stationary state. So the first line of Pfund series, that is photon emitted of the minimum energy, will be of the transition of electron from the 6th stationary state to the 5th stationary state or the 5th orbit. So the energy gap between the 6th orbit and the 5th orbit is minimum in case of the Pfund series. So the first line, that is the photon emitted of the minimum energy photon emitted will be of the transition of electron from the 6th orbit to the 5th orbit. So the first line will be of transition of electron from 6th orbit to the 5th orbit. Now the limiting line, the last line, you can see that the energy gap between the infinity and the 5th orbit is maximum in case of the Pfund series. So here the photon emitted will be having the highest energy. So the limiting line, the last line, comes out to be the transition of electron from infinity orbit to the 5th orbit. So here I'm writing the limiting line will be obtained from infinity orbit to the 5th orbit. So that was the hydrogen spectrum. So let me give you some here a little clue. So first of all, you can assume that these lines are Lyman series. Now after a bit distance, you will get the lines of Balmer series. After that, you will get the Bastion series. That's the lines of Bastion series. Then there's the line of Brackett series. That's the Brackett series. And finally, there are the lines of Pfund series. So these are the Pfund series. So I'm writing Lyman, Balmer, Bastion, Brackett, and a Pfund. So now, uh, let's talk about a bit detail about the different series. So I'm first of all writing here Lyman series, and here I'm writing Balmer series. Now let's talk about Lyman series first. In case of Lyman series, the photon of minimum energy, that is the first line. That first line of the photon of minimum energy is the first line is obtained by the transition of electron from second stationary state to the first stationary state. So the first line or the photon of minimum energy emitted will be of the transition of electron from the second stationary state to the first stationary state, and this is the minimum energy gap for Lyman series. Now let's talk about the Balmer series. In case of Balmer series, you can see that the limiting line, the last line, or the photon of maximum energy that have been emitted by electron will be of transition from infinity orbit to the second orbit. So in case of Balmer series, the photon of maximum energy will be emitted for the transition of electron from infinity orbit to the second orbit. So here I am writing maximum energy gap for Balmer series. Now it has been scientifically proven that the minimum energy gap of Lyman series is greater than the maximum energy gap of the Balmer series. So here what I'm trying to explain, that the minimum energy gap between the two orbits in case of Lyman series is greater than the maximum energy gap between the two orbits, that is from infinity to 2 in case of Balmer series. It proves that this thing proves that here I'm writing it further proves that lines of different series, that is Lyman, Balmer, Paschen, Brackett, Pfund, will never overlap with each other. So that's why I have made this diagram over here. To show you that different series of lines are not at all overlapping with each other. That is, Lyman series has some energy gap between the Balmer series, have some energy gap between the Paschen, has some energy gap between the Brackett, and finally the Pfund. So there is no overlapping of lines, and its reason is that in case of like Lyman series, the minimum energy gap of transition, that is of 2 to 1, is higher than the maximum energy gap of Balmer series, that is from infinity to 2. Now let's talk about the Balmer and the Paschen. In case of Balmer, the minimum energy gap of Balmer series will be greater than the maximum energy gap of the Paschen series. That's why they will not also overlap with each other. Now let's talk about the Paschen and Brackett. The minimum energy gap of the Paschen series is greater than the maximum energy gap of the Brackett series. That's why they will also not overlap with each other. Now in case of Brackett and a Pfund, in case of Brackett, the minimum energy gap of the Brackett series is greater than the maximum energy gap of the Pfund series. So that's why Brackett and Pfund will also not overlap with each other. So that's all for today. This was the today's lecture about the hydrogen spectrum. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.